Okay, guys, I've done what I wanted to do. Now what I'm going to do is to share my screen, of which I believe it is now sharing, and I would like for someone to just confirm if indeed my screen is
Yes, sir, your screen is
sharing.
sharing.
Guys, my screen. Is everyone able to confirm if it is indeed sharing?
Yes, sir, it is.
Okay, then it's fine. It's fine. It's fine. It's fine. So I'll just hear from you if you will need this document. We might not necessarily need to go through everything, but I just want you guys to have a sense of what is expected of you when you practice to prepare for examinations. Let's maybe quickly have a look at those basic equations. I'm mostly interested in the fractions, honorable members, because in mathematics, if you haven't mastered how to work out the fractions, you're always going to be in trouble. You will find the fractions when it comes to the functions, especially the hyperbola, because its format is such that it has a fraction. If you're not able to work out those, then you're going to be in a big trouble. Remember, guys, we have covered all that we needed to do. You might find that there are some specific topics that you would like to revise. Just let me know via WhatsApp inbox so that I can refer you to where those lessons were saved. It makes it easier for you to do revision. You just need to make sure that, okay, there you are, seated, or you might be preparing to go to bed. You want it to write, you just watch the video and then it will take you through everything that we have done. All that you need to do is just to have the ability to absorb the information without having to write. Maybe before we jump onto those fractions, let's maybe have a look at these basic equations. I'm just going to explain just so that you've got a sense of how you need to be preparing for examinations. And then from there, you will let me know if what I'm doing, it makes sense. So you look at, let's say, number one, honorable members. The first thing that you need to know is that this is an equation. Why? Because it has an equal sign. And for that reason, it means you must solve. What are you solving? You are solving for the unknown. The unknown is always a letter in mathematics. So in this case, you can see that the letter that is used is x. So since it's an equation, it means we are solving. What are we solving? We are solving for letter x. Now, the question is, how does our final answer look like? When you look at this that we call equation, because it has an equal sign, what type of an equation is this? Is it a linear equation or is it a quadratic equation? It's in most cases where at your level you will be I'm just not so sure if I got disconnected there. I saw a message popping up. Um, Guys, I think it was my screen that disappeared. It's now sharing. Let me check what Menlong is saying. I'm just, you are disconnected. Okay, Menlong is saying I'm disconnected. I just want to verify. Guys, am I still disconnected or can you hear me now?
I can hear you now, sir.
But I'm not sure to what extent you were able to hear me on that one. Maybe when I circled that number 1, did you guys hear what I was talking about there? Maybe not.
No, sir.
Okay, then it's fine. I'll just summarize. So I was saying, in most cases, at your level, you will be given either a linear or a quadratic equation that you need to work out. So what makes an equation a quadratic equation? That's what I circled when I was saying every time when you see letter, which is to the power of 2, always just know that it is a quadratic equation, always. And then now, before you can work out a quadratic equation, you need to make sure that it is in the standard form. The standard form, we talk about ax squared plus bx plus cx, and everything has to be equated to 0. Always when you have a quadratic equation, everything must be equated to 0. If it's not equated to 0, then it is not in the standard form and you need to rewrite it in the standard form. Only after it is in the standard form, that's when you can factorize and then you say x is equals to this or x is equals to that. These two, honorable members, it tells you that you must have 2 possible answers. So that is why always when it comes to a quadratic equation, you'll always have 2 possible answers. Okay, maybe let's look at number 2. You look at number 2 and then you realize that this is an equation. Why? Because it has an equal sign. That is number 1. That means you must solve. Why do I have to say it's an equation because it has an equal sign? It's because if it does not have an equal sign, we call it an expression. And in expressions, we simplify. So that means we just rewrite what has been given in its simplest form. We are not solving. But the moment you say an equal sign, it means you are solving. What are you solving? The letter. What letter is used here is letter X. But now the last important question, what type of an equation is this? Is it a linear or is it a quadratic? And the moment you see that letter to the exponent, as long as there's exponent 2, it makes the whole of this to be a quadratic equation. Those of you who do not know how a linear looks like, a linear will just be, for example, 2x plus, for example, 7, it could be equated to x. When you look at this, all the letters are to the exponent of invisible 1. That is a linear equation. So this one, it means you'll only have one answer. Meaning as you work out this, you will end up just saying x is equals to whatever. But this one that has to the exponent of 2, it means you will have x is equals to that or x is equals to that. If it was 3 there, it means you're going to have 3 possible, and if it was 5 possible. But at your level, in most cases, it's up to 2 or 3. Most cases 2. So now, the most important question is that quadratic equation in the standard form. So it is the quadratic equation that you need to worry about it being in the standard form. When it comes to linear, it doesn't need to be in the standard form. But always for a quadratic, it has to be in the standard form. You look at this, you can see it's not the same as that because it's not in that format of ax squared, bx squared, and c, and everything must be such that if equated to 0, which means you can take that to the other side. And then from there, you equate it to 0, you factorize, you find the final answers. So that's how you do maybe number 3. You look at number 3, just say, okay, it's an equation, it's a quadratic, it's in the standard form. What I'm going to do is to factorize and then find 2 possible answers. You are done. No need to write. Look at this one. Okay, it's an equation because it has an equal sign. It means I'm going to solving for x. Is it in the standard form? No, it's not. Then I will need to rewrite it in the standard form. Take 1 to the other side, equate it to 0, and then factorize, find 2 possible answers. Then you are done. So that's how I used to prepare for examinations, honorable members. That is because an assumption is that I've done all of these things during the course of the year. I'm not going to be doing them for the first time. So that means you must have done everything, honorable members. All the topics, for all the topics, that includes also the functions, because when it comes to mathematics, there's no room for mistakes. You just need to know that, okay, if this is what I'm given, you look at this, you see an equal sign, it means it's an equation. What type of an equation is this? It's a quadratic. Is it in the standard form? No. You need to take 10 to the other side. It has to change a sign. So you can't expect your teacher to teach you to an extent that you will never forget not to change a sign. That remains your responsibility, honorable member. You need to make sure that you've done it multiple times, such that even if you are very much worried or anxious or whatever the case may be, or you are frightened by the examinations, it shouldn't be that you still forget that when you take the 10 to the other side, changes the sign. Take 8 to the other side, changes the sign, and then you remain with 0. Then you factorize decisively. So that part, it shouldn't be complicated if you have done the basic equation. But now, this is where now you are having some problems when it comes to the fractions. I've checked many of your submissions on different exercises that I've given you. What you guys are struggling with the most, it's something that has to do with the fractions. When it comes to problems where you have to involve the loss of exponents, you don't seem to be struggling that much. But here, this is where you guys are seeing flames. I will just go through the exam type of questions. With the others, you might not need to expect them. But I will go for those question like question number 15. So what you might expect. The reason why I'm saying that one is because something like a hyperbola in terms of its functional equation, it may be structured similar or closer to that. And you will be expected to perform calculations by looking at that. My concern is, at this stage, are you able to look at that and be able to know exactly what needs to be done? Or maybe before I even look at that number 15, let me just check. Did you guys understand what I was trying to explain for those basic equations? Or is there someone who still doesn't understand what I was explaining there?
I understand, sir.
But not only how to answer those questions, honorable member, I mean, in terms of what I'm trying to demonstrate regarding preparations for examinations. When I say you look at that, you analyze it, and you must know what to do with an assumption that you won't make any mistakes. Because it's more like you are just practicing how to mistakes. And this is to train yourself many times such that you will never repeat a mistake of forgetting that you take something to the other side. Because it's a common mistake, honorable member, as much as it might sound simple, but it's what most of you guys do. The thing is, you do it and you don't realize, and you never know that that's what you did. So that's my question to say. Did you guys understand the demonstration in terms of how you prepare for examinations?
Yes, sir.
Got a response from Mendy. Okay, there is Sam.
Yes, sir.
Okay, then it's fine. It's fine. So now let's look at this. Let's look at that 15. I would like to give it to you as a question or as something that one can just rise on a point of order and say, I would like to give it a try. You just do just like I did with those basic equations. Let me not say much so that I don't give you guys a clue. But anyone who would like to explain how to analyze that question number 15. No need to write it down, honorable members. Remember, what we are doing now is just to train on how we can prepare for examinations without having to write anything, no calculator needed, but we just discuss in terms of this is what needs to be done. So as a leader, you should be knowing what needs to be done, and then you explain to your workers in terms of this is what needs to be done, and this is how you do it, and then you move on to something else. And then your teams works on it, and when they struggle, they come to you, but you must be the mastermind. Anyone who would like to rise on point of order and explain to us what needs to be done there.
Sir, you are going to.
Who's speaking now?
It's to. Say it's to.
Oh yes, okay, go for it, honorable member.
So
what needs to be done?
You first have to find the LCD so that you multiply each term by the LCD.
Okay. What would the LCD be in this case?
2x minus 1.
2x minus 1. Okay. Then what are you going to do with that again?
You multiply each term by that LCD.
Okay. Then what's going to happen to each term?
For the first term, the LCD and the denominator are going to cancel. Then you have x plus 1 left. Then with the second term, it's going to be plus 2x minus 1 is equal to 0. Then you simplify.
Okay. Anyone else who would like to oppose or who has a different view on that number 15 before I give my comments? Guys, anyone who would like to oppose, give a different view on what Chiro has said? You are cracking. I think that was Chiro speaking now. Guys, yo, any comment from your side on it? Onele, Amanda, guys, are you still there?
Yes, sir.
Yes, I just wanted to check if there's anyone with a different view or if you oppose what Chiro has said on that one.
No, sir.
For the purpose of making progress, I will say something. So, you are 100% correct, honorable member. Trust me on that one. So, you can say you will find LCD, and then you take your 2x minus 1 as your LCD, then you multiply each term by that LCD. Then the first one, yes, it will cancel. that other one, it will remain as your LCD, and then you equate it to 0 because anything multiplied by 0, it is 0. Then you end up having a linear equation. So that means the first step, it is to make sure that you convert this fraction into a linear equation. It's very much easier to deal with linear equations as compared to dealing with the fractions. So the other way, Tiro, of which you will never forget, especially that you are the one who suggested how to work out this one. Are you aware, Tiro, that if you take one to the other side, then you can cross multiply. Then you avoid looking for the LCD. Can you see this open? Does it make sense to everyone? Or do I need to write it down?
So I understand. It's just that with cross multiplication, I get confused. So, yeah.
Yes. Then at least you've got another way of working it out. So it just depends on preference. So this is what I'm saying, honorable members. You can still say that. You can still say that. So what I'm saying is this one, you take it to the other side. And when you take it to the other side, it becomes -1. So what I'm saying is, if you have a fraction on the left, you can also fractionalize this thing on the right-hand side. Why would you fractionalize it? It's so that you can say that multiplied by that, and then that multiplied by that. This is just in case if you are not sure about these things of the LCDs, because if your LCD is wrong, everything is wrong. But with this one of cross multiplication, it helps you to avoid having to worry about what your LCD is going to be. Maybe let me give you an example so that you understand what I mean when I say, in case if you are not sure about these things of the LCDs. Let us say, for example, this was over X. You see now, it's not everyone who will know what the LCD will be in that case. So what I'm saying now is you will therefore have your X plus 1, which is equals to X minus 1 is equals to. Then you take the whole of that fraction. You can even take that negative and assign it to that, and then you say over X. So now can you see, you won't need to worry about knowing what the LCD is, but you can just easily cross multiply. Does it make sense what I'm explaining there, honorable members? So what I'm saying is, once you know that you need to cross multiply, then going down, it should be an easy thing to do. We don't need to write that, especially during this time. It's what we've been writing during the course of the year. But do you understand what I'm explaining there, honorable members? Or am I losing some of you?
I understand, sir.
Is it everyone who's
Sir,
okay? Yes.
sir, I don't understand your method.
Is it on this question that I said over X, or
Yes, sir.
is it okay? Maybe very quickly explain part. Who's speaking now?
It's in it, sir.
Who was speaking? So what I'm saying there in it is that remember, if you have, let's say, X over 3, to cross multiply that multiplying that and that multiplying that, so that means it is 3 multiplied by X is 3X, which is equals to 2 times 1, which is 2. Then you are easily going to remove 3. by dividing on both sides. X is equals 2, then it means it's just 2 over 3. Just this part, does it make sense? Just this part.
Yes, sir, it does.
Okay, so now let's apply the same explanation on that one. So can you see here, that one at the top, it multiplies with that x. So that means we're going to have x, which is multiplying with that x plus 1. And then this is equals to, can you see there, we have -1. That -1, it is going to multiply with that thing at the bottom. Then it will be that by that, obviously that is x squared, that by that will be plus x, which is equals to that by that will be -2x, and that by that, it will become +1. Then you see now, because of this, it is a quadratic equation. What does it mean? You need to rewrite it in the standard form, where now you must have that, this to the other side. Trust me, it will become 3x, that to the other side minus 1 equals to 0. Then we are back to those basic equations where now you need to find the factors and you work it out. I'm not sure, does it make sense, Sinit, what I'm saying here? This is what Chiro says I'm not confident
Yes,
with,
sir.
and she would rather do the LCD, of which she will still get it correct. It's just a matter of preference. So this method, does it make sense now, Sinit?
Yes,
Before I
sir.
erase, let me check with the other honorable members. Guys, are we all on the same page on that one?
Yes, sir.
Understand? Okay. Guys, are we okay? There's good. Okay. Then it's fine. So what I was saying, honorable members, is that during the time of exams, I shouldn't, and you shouldn't, be writing all of this. That's all that I'm trying to say, which meant Lonke said he fully understand what I'm saying, because can you see, the moment you start writing all of this, it takes much of your time. So to save that time, you must have done all of this throughout the year. And then what you now do is just to look at it and say, okay, this one, I'm going to do this, do that, do that, do that, do that, do that, do that, with an assumption that you will always remember that taking to the other side will change the sign, and then you do that. So it's more like you just need to be a mastermind to know what needs to be done, this is what needs to be done in this case, this is what needs to be done in this case. It's not only these questions, but let's look for the last one and maybe jump onto a different one. Maybe let's look at let's say 21. Anyone very quickly who would like to rise on a point of order and explain what can be done for that 21?
So I think we must cross multiply.
Who's speaking now?
Juanita, sir.
Juanita, 100% honorable members. But now, Mtakaditsela, what would you then do in this case? I'm interested to know, what would you do in this case, Cheho?
So my LCD would be x plus 1 multiplied by x minus 7, but like
Okay.
in brackets. Yeah.
Okay, so your LCD is your way to go for everything you say, ne?
Yes, sir.
Okay. So it's either you do it the Juanita way or the Chero way, whichever way that works for you. So with Juanita, she's simply saying this you multiply by that, and then that you multiply by that. So obviously, you will need to have this inside the brackets, also that inside the brackets, you multiply those, and then this you multiply it with that. Then you will do that by that, that by that, that by that, that by that. That's what the honorable members are saying there. So who will do it using the LCD method. But Does it make sense, honorable members? Can we make a conclusion on this one and move on to a different type? Does these type of problems, are they clear in terms of how you approach them? To everyone, are we all okay?
Yes, sir.
Okay. Maybe here's the last one. Let's look at 28. Yes, for 28, yes. What would you do for that 28?
Sir,
Mm-hmm.
I would use Tutor's method and I'll find the LCD in this case, which I believe is x, and then I'll multiply everything by x, which will give me a quadratic equation, and then from there on I would solve for x.
Exactly that, honorable member. Then you are done on this one, and then you move on to something else. This is you looking at a past exam question paper. You just look at a question and say, this is what I'm going to do. Then you move on to the next one. We're also not going to waste our time on that one. Then we move on to something else. Who are speaking there on that one?
It was me, Sinitsa.
Okay, then now let's move on to this type of questions. Maybe let's start with 35. Anyone who can suggest how we can approach 35? What needs to be done on 35?
Sir, can I try?
Yes, go for it.
So you say we have to do 35, right? Am I correct?
Yes.
So what we need to do first, in order to get rid of the square root, we have to square both. We have to square it. But what we do on one side, we need to do on the other side. We need to square both sides, which will cancel out the root sign and leave with x plus 3, which equals to 4 to the power of 2, which is 16. Then that 3, you transpose it to the other side, which means x will equal to 16 minus 3 equals to 13.
Okay. And then now, let's jump on to number 39.
Sir?
Yes, go for it.
Can you actually I would use the same way as the previous learner said, but can you please like focus on, well, can you please show how we can solve like 37? I don't understand those questions.
Which one? You said 37.
Yes, sir.
Okay. Then it's fine. That means we also have 37 to deal with. But in the meantime, let's then jump on to 39. Then afterwards, we'll go to 37. Anyone who would like to suggest what needs to be done on number 39? Guys,
Sir?
number 39. Yes, go for it.
You would square both sides by 2, and then which will give you a quadratic equation. Then you take x plus 15 to the other side, which will give you a quadratic equation, and from there onward you solve for x.
Okay, you skipped the most important step that I'm interested in. But from where you started going down, you are 100% correct. But what happens when you square? I just want to know that step.
So when you square both sides, the square cancels the square root, which will leave you with x plus 15 on the left side. And then on the right side, it will give you 16x squared.
Okay.
So in order for you to solve for x, you must put it in standard form, which means that you have to
100%.
take x plus 15 to the other side, which will give you the standard quadratic equation, and then from then onwards you can solve for x.
100%. Hey, who's speaking now?
It's Sinita.
Okay, but wait, Sinit, do not mute yourself. You are the one who suggested that 37, eh?
Yes, sir.
Okay, so the reason why I wanted that step, it's because the other honorable members, this is what they do. They do that, they square, and then they do that, they square. But now, after removing that square root, having x plus 15, I'm sure you already know, they say 4x squared. That is the mistake that they make. They get it wrong, and because they got it wrong, an assumption is that is difficult. Not remembering that the laws of exponents, they say if you have a and b, this thing is the same as that 8 multiplies invisible 1, another invisible 1 there. So it's a to the 1 times 2, which is 2, and then b to the 1 times 2, which is 2. Trust me, Sinit, it's many honorable members who do that. That's what I was saying, explain that part. So now, Sinit, there's no way you can do 39 and fail to do 37. Go for it, honorable member. You will see that it is just a fear that you are having, but you can actually do it. Go for it.
Okay, so you are going to square both sides by 2, but you are going to square both sides basically. So as you said, you multiply the 2 into everything that is in the bracket. So 4 squared will give you 16. Then since 4x plus 9 are under the square root, the square will cancel the square root, which will give you 4x plus 9. And then on the okay, so if I'm not mistaken, you're going to multiply 4x plus 9 by 16. And then on your right hand side, because you squared your left side, you must also do the same on your right side. So you're going to get 9x squared plus sorry.
So basically 2 of the same thing, in short.
Yes, what you do on the left, you do on the right, basically.
So it's done, Sinit. It's done. You are 100% correct, honorable member. So can you see that
Really?
it's just the fear that you have, because it looks like it's complicated, but it's not. Exactly what you said is 100%. You just need to know that the rule says a multiplying by b. So that means in this case, this is a multiplying by the whole of this is b. So now, if you are having that 4, which is now 16, if that is multiplying the 4x, that is plus 9. Because of this sign of a plus, it forces you to have this thing inside the bracket. And then that is equals to 2 of the same thing. And you know how to remove those brackets. You are forced to say that by that, that by that. Does it make sense to all the honorable members of the opposition parties?
Yes, sir.
Guys, are we all on the same page on that one?
Yes, sir.
We must just make sure that there's no one who is falling behind or afraid to say they do not understand. Sam, you will need to unmute and say the honorable member, because if you text, I'm no longer sure when the text came through and which one were you referring to?
Sir, I'm referring to the previous question, sir.
Kabisa na vile oyo monike kongola kofanda kuna tata docteur akofanda na vile wana tomona kaka vile wana kama américain akofanda kuna te kunesaka ba abisaka kaka omona ba ba niveau moko fonza ndako
which one? The okay, which one in terms of number? There's a background noise and I'm not longer able to hear what Sam has to say. Okay. I'm just not so sure.
Sir, 37, sir.
Which one? Number 37. Okay. The one that the honorable member was not sure of, and she has explained it correctly. Sometimes it's just the issue of confidence, the honorable member, because you become less confident when you're not sure about something. But you will find that if you start doing what is doable, then it leads you to complicated problems. And those complicated problems, you can actually do them. So that's why I always encourage that. Do not always start with something complicated. That is why, Sinit, if you've noticed, we started with 35. Instead of us jumping on to this one, we had to start there, you see, because now if we go there, it's a bit more complicated. Rather do that before getting to that one, because this one, it prepares you to get onto that one. So that's what happens generally, honorable members. With the other honorable members, they just want to do some complicated problems only, not realizing that that is not the way to go, honorable members. In my case, I used to make sure that when I study, I firstly do doable things. Start with the doable things, so that they encourage you to do more. But the moment you start with something complicated, if you lose confidence or you don't know what to do, I'm just not so sure. But it used to happen to me where I lose interest completely on studying on that day or at that particular moment. I just feel drained. I lose the energy and I feel like just stepping away for a few minutes, could be hours, then come back later and try to continue. So that's what I'm encouraging you to do, honorable members. It's just something that is to do with the psychology. You will never notice until time is gone that actually I did had the desire to study, but I couldn't study. And I didn't even know why I couldn't study. Sometimes it's because of the starting point. Just make sure that when you study, start with the doable things. They will encourage you to do more. And with you having to do more, that's when you get into some more complicated problems. Trust me, honorable members, with you doing those doable things, especially the same way we are doing now, it's going to make it easier for you to not even feel when you do some complicated problems. Okay, number 39. So this is what we are saying is always, let's say, for example, we had square root of x plus 15, it's equals, let's not say equals to, but let's say minus 4x. Maybe it's equated to 0. So the basics or the format is such that you must always isolate a square root. In short, you must always show that everything is on the other side and you just leave the square root on the left-hand side. You mustn't forget that there is an invisible one there. If it's not invisible one, it could be a half. If not half, it could be quarter. Sometimes it could be 2. Just know that there's something there. There will always be something there. Just know that. So when we say you isolate, whether it is quarter or whether it is half, you just leave it on the other side. So that means if there was half there, you will say this half and then you have x that you plus it by 15. Can you see? You need to take this thing away or to the other side and it changes the sign. Just so that on the left-hand side, you leave the square root only on the left-hand side. So now what we are saying, remember, in this case, there is no half, there is no half. We are doing that number 39. So what Sinit was saying there, you need to square root both sides. The reason why you had to take this thing to the other side is because you had to square root both sides so that that square root cancels with that. Okay, there's 1 there. What is 1 to the exponent of 2? It remains as 1. So that is why nothing much changes there. Meaning if it was 2 there, then it would be 2 to the exponent 2, which makes it 4, and then the square root cancels with that. Something that you might be interested to know, I'm just not so sure if I've explained this. Just know that square root, for example, of 2, there is an invisible 2 there. So the reason why we remove a square root by 2, it's because we are trying to cancel this 2. So that means if something is square root of 2, just know there is an invisible 2 there. This thing can be written differently. Remember, there is invisible 1 there. There are a lot of invisible things there. There's also invisible 1 there, but let me not complicate it. Okay, so now this thing, it can be written as 2. You see that 1, you write it there, and then you see that 2, you say to the exponent of over that. So the reason why when we say we remove a square root by squaring both sides is because when you square, then you have this half multiplying that 2. Then that 2 will cancel with that 1. And you have 2 to the exponent 1, which is the same as 2. So it mustn't just be that you know that, okay, to remove a square root, you just square both sides, but not knowing why do you square it? Why do you multiply by to the power of 2? As a mathematician, you need to ask your question to say, why are we not multiplying it by 3? Why are we not multiplying it by half? Why are we not multiplying it by 1,000? Who said we must multiply by 2? Or where is the 2 coming from? You must understand mathematics to that extent. So that means one day if you have 3, let's say square root of x minus 1, this is just as an example. You must know that to remove that square root, you are not, honorable members, going to say, I'm going to square it because it's a square root. This is no longer a square root. Is it cube root of something? Maybe it's cube root of something. But whether you know if it's cube root of something or not, you must just be aware that this thing can be written differently. How can it be written? It can be rewritten as inside obviously is x minus 1 to the exponent of 1, that invisible 1 there, over that 3. So That means, honorable members, to remove that, in this case, you multiply by 3. Why 3? So that that 3 will cancel with that 1. So it doesn't mean every time when you see a square root, you'll always remove it by 3. If it is 4 there, then it means that 4 will be there. To remove it, you multiply it by 4. If it's 70 there, then it means it's whatever over 70, and then that. Maybe lastly, let's say we have, let me exaggerate it. Let me exaggerate it. So that means this one, it can be written as, then in this case, it will be x 2 over 1 over 4. So now to remove, if you had to remove this thing, so can you see it forces you to multiply by 1 over 4. So that means you just multiply by whatever that is. That's how you remove it, because that 1 over 4, it will cancel with that 1 over 4, and then you just have that. So if it is just square root of x minus 1, just know that there is invisible 2 there. Just like when you write x, there is an invisible 1 there. There is an invisible 1 there. There is an invisible positive there. Invisible positive there. It's not necessary to write, but you just know that this thing is the same as x, but it has got too many invisible things. There is an invisible plus there. If a number is just a number, just know that it's a plus. Unless if it's a negative number, then we will mention, say, negative 1. Guys, did you understand what I was saying there? Did you guys
sir.
fully understand what I was explaining there?
Yes, sir.
Because this type of understanding of mathematics, it's what you're going to need, especially that honorable member who's doing actual sciences. Yeah, I hope you guys saw that message. That is the level to which you're expected to understand mathematics. You mustn't just be multiplying things, knowing about the LCD, but you don't really understand in the background to say what's actually happening. You know, when someone does programming, as the user of an app or an application, you just know that, okay, when I press here, this is what happens. When I press here, this is what happens. When I do this, this is what happens. But the person who programs, they need to understand even more. For example, what I've just explained there, to say, why do we use 2? You need to know why. But someone who's going to be using your app, they don't necessarily need to know why that number. They don't necessarily need to know why this happens when you do that. But yourself as the programmer, as IT specialist, you need to have a deep understanding of everything. And understanding that if you put a comma there, this is no longer 2,200, but is 2,200. If you put a comma there, the whole of this changes. It's going to be something completely different from what you can imagine. So just by all means, honorable members, if there's something which is being done in a particular way, be inquisitive enough to try and understand why. Always ask yourself the question why, even if you don't have the answer for that question, but just note it down to say why this. There is going to be a chance where you can ask and say why this, why this, why this, until you get an explanation as to why. Okay, let's see. There are more problems which we could have gone through. That includes also the inequalities. We also have simultaneous equations, honorable members, where when it comes to simultaneous equations, luckily there is a lesson that we did beginning of the year where we focus on simultaneous equations only. So can you see at this stage, you don't need to write all of these things, honorable members. You just look at it and say, okay, if I'm given number 67, how am I going to start? Okay, easily you can say, for this one, I can just take this thing and then put it there. Then solve for x straight away. You don't need to make x or y the subject of the formula. Already they've made it for you. All that you need to do, you can take, substitute, or put it there, and then you start working. That is what needs to be done for 67. You don't need to write it down, honorable members. That's what I'm trying to say. Maybe when you look at 69, you realize, okay, I will need to make something the subject of the formula. The question now is, are you going to use this equation or are you going to use that equation to make equation number 3? How are you going to decide? This is how you decide. Between that first equation and the second one, which one looks more complicated? The second one looks a bit more complicated. Why? Because of having those x squared and wara. Rather, don't go for that one and maybe consider going for this one. So in short, what I'm trying to say, one can still decide to go for that one, it's fine. But what I'm trying to say is that you make use of a less complicated equation to derive the third equation. Normally, it is linear equations that you can use to derive equation number 3. Okay, it might not make sense what I'm explaining. Very quickly, let's jump onto 71. You see 71, you have this as your equation number 1, you have this as equation number 2. So what I'm saying is, look at equation number 1 and equation number 2 and ask yourself a question. Which equation is less complicated? The one that is less complicated is the one that you use to derive equation number 3. To me, it looks like equation 1 is less complicated, because if you take this x to the other side, it changes the sign, it becomes positive x. And then if you take this thread to the other side, it changes the sign, it will find 2y there, and then it changes the sign, it becomes -3. Then everywhere you see x, you just put that 2y minus 3. Then you start working with an assumption that even as you work it out going down, you will never make a mistake, because that's what we can help you with during exam, honorable members. As a teacher, as a tutor, as a lecturer, we only tell you what you need to do. At secondary level in high school, we also show you how you work them out. But when you get to tertiary, honorable members, if it happens that you get to tertiary, they will just say, okay, 71, 69, 67, that is your assignment. You need to work those things out. Then it remains your responsibility to look for a textbook that deals with this type of problems, and then you work them out. You practice on how to work them out. All that they need from you is the solutions to these problems. This is so that when you get to the ways, you will be given a project that you need to start and finish it. So you need to start to be at a point you can think on your own, apply your mind, and provide solutions. Okay, let me not go deep so that some of you guys can prepare for the next day. But for now, let me just confirm, guys, did you all hear everything that I was trying to explain?
Yes,
Yes, sir.
Okay, okay, guys. Trust me when I say my name starts with a letter D, and I